Hey Dr. Zhang, so here's our first project for heat transfer, and it's on conduction. So I thought, well, what would be a better way to show conduction than using an oxyacetylene torch and heating up some metal and measuring the temperature on both sides? Well, probably a lot of things, but I thought this would be funner for you to watch, so let's get to it. Alright, so for this experiment, we'll be using an oxyacetylene torch to heat up a piece of raw metal that we can measure the area and the thickness of, and after about 10 to 15 seconds of heating it up, I'm going to measure the front side temperature and the back side temperature and try to get a good estimate of the temperature so we can figure out how much energy is coming out of this torch. So let's get to it. So after measuring it, my front side temperature was riding around 160 and the back side temperature was riding around 148 degrees Celsius on both of them. This thing's not the most accurate, but we're going to use it for both things, so we'll get a pretty constant answer. So let's go see what the math says about this. So let's look at the math for this heat transfer. So what we're trying to find is the energy output of the torch. So we're going to use our conduction equation, Q equals negative Ka times dt over dx. And we can find the area and the thickness by measuring the iron plate that we cut. So we measure all that, and then with our two temperatures we found from adding the heat, we plug it all into our Q equation, and we get Q equals 581.6 watts. So the torch is putting out 581.6 watts of power. And there's a lot of different variables that could have affected our answer. There's a lot of convection happening in that shop. The torch isn't putting all of its heat evenly onto the piece of iron. The temperature gun is not super accurate, and there's also radiation. So there's a lot of things that could have affected this energy output, and but I found some sources on the internet that showed that the energy output of the oxyacetylene torch is about 500 watts. I found a source. So this isn't too far off, but there are a lot of things that could have affected this, so I wanted to address those. But overall, this was a fun experiment, and I'm glad that we get to test these things in real life. So, see you on the next one.